you. So welcome everybody. Let's start because we're running a little bit behind as opposed to this morning. I want to tell you something about fiber to the home. You heard me on the panel a little bit already, so you know what I do. And I want to bring across that there's more than just technology. We heard a lot about technology today. We will continue. We are in the business of technology, but there's more in order to achieve success. So let me start by saying we are all very hungry. Lunch was a while ago by now. I won't try to hold you up too long for the cocktails later. But why is that? Well, we want more services all the time. And these services are using more and more data all the time. And we want to use this on more devices. You all know the statistics of how many connected devices the growth is. And we want to use this everywhere. And this is not easy, right? If you have more services and you combine that with more data and you combine it with more devices and multiple locations, as I said, this is difficult, which is why we're here. And one of the things I want to say is the key to this problem is in the home. And why is this? Well, first of all, we spend a lot of time indoors. There have been many studies done in the past. We spend about 90% of our time indoors, and most of that is at home. So that's why I think we're in the right business of fiber to the home. But let's take a step aside and tell you something about city traffic, because there's something we can learn from that. So once upon a time, traffic looked like this. But you know, times have changed. What we see is people are more mobile, more than ever. They want to get to more places, they want to get there faster, etc. So if we look at city traffic today, what we see is a couple of things. First of all, looking at the cities. Cities are very diverse. Every city is different. And that's partly because every city is historically defined, sometimes by the waterways that connect them, the geology, hills, etc. So very diverse, historically defined, continuously evolving. If you look at the city today, also London, you see old buildings, you see new buildings. Everything is constantly evolving. And also is largely uncontrolled. Maybe not individually. If you have a patch of ground and you're building a home, then you are in control. But there are a lot of existing buildings that you can't just wipe away and rebuild and replace. So if you want to do something in a city, you basically have very little control over what you can actually achieve. So you have to do what I call low impact planning. And here are a couple of examples to illustrate. You might recognize something. The first one, top left, is Manhattan. It's very grid-like. Manhattan is, of course, comparatively modern. So they did a very nice layout, depending on your point of view, very grid-like. Then the second one in the middle is Amsterdam. It's a more curvy place, built around the center with the canals. So you see more variation. The last one is London, centered around where we are today, in fact. And you see again a very different picture. So it's clear all these cities look different. If we look at the traffic in cities, we see that traffic is very dynamic. You all experience it. I experienced it this morning in the underground. It's very dynamic. You have rush hour. Everybody wants to get home or get to work at the same time. And then if you go after midnight, I was traveling from my home to the airport between 4 and 5 a.m. this morning. Almost nobody on the road. It's nice to drive. It's not so nice to get up so early, but it's a really nice, quiet drive. So it's very dynamic. It changes by the time of day, holidays, etc. There's also many different types of traffic. Pedestrians are walking around. There's bikes, cars, buses, subways, you name it. All different kinds of traffic. And then there are many, what I call services here. People travel. Why do they travel? They travel to go to work or to go back home. They travel for entertainment purposes, go see a movie, for example. They go dining, they go shopping, Lots of different reasons why people travel. And I would also say traffic is somewhat managed. There are traffic lights, there are rules. You cannot manage everything. You cannot tell people when they are allowed to go on the road. You can influence it a little bit. I believe you have a congestion charge here, for example. So you can try to influence people, but ultimately also there you have only limited control because people will try to get to where they want to go, when they want to go. So what that reminds me of is city traffic looks a lot like the digital home. And why is that? Well, if we look at homes, homes are very diverse. If you look around, you have big homes, small homes, etc. Very diverse. They're also historically defined. Most homes weren't built today or this year or last year. Some homes are hundreds of years old. They've been remodeled over time. The function of different rooms in the house changed, etc. So they're continuously evolving as well as people adapt the homes to their needs. When you get children, when they grow up, leave the house, usage changes. They're also largely uncontrolled, and in this sense, I mean by the operator or the ISP. If the operator cannot go to your home and say, look, if you have a bad Wi-Fi connection, rip out a wall and your Wi-Fi will be better. It's not going to happen. So from this point of view, homes are also largely uncontrolled. And a couple of examples. So at first you see a view from Amsterdam, the top left. Houses that are quite narrow but very tall. And then on the bottom right you sort of see the opposite, houses that are not so tall but very wide. So this is already interesting from one aspect. If you try to cover the whole home with Wi-Fi, you cannot just make a solution that tries to optimize in a certain direction, because you don't know what home it will be used in and maybe what the device orientation will be. But apart from individual homes, you have apartment buildings. Then each home is a bit smaller. So lots of different variety. And if we look at the data or the traffic in the homes, you see the same thing again as the city traffic. Data is very dynamic. It's not a coincidence that we have something called the internet rush hour. I think it's around 7 p.m., 8 p.m. People get home, maybe they finish dinner and then they sit in front of the TV. And these days people don't sit or sit less in front of the classical linear TV, but they watch Netflix over the top. Or even if they watch TV, it's often IPTV these days. So a lot of traffic. And again, same thing as on the roads. After midnight, it quiets down. There's not so much to do. Many different types of traffic. You have traffic that requires high bandwidth. We saw also this morning Ultra HD TV, these kind of things. Apart from the improvements in compression, it's still pretty high bandwidth. You have other traffic that requires low latency or low jitter for different services. Some things require high reliability. If you do just download a web page, then you might get a couple of TCP retransmissions, not a big problem. But if you're watching TV and it's multicast IPTV, for example, then packet loss means that you will see this on the screen. You get glitches, it's not what you want. So many different types of traffic. You also have different services, the classical ones, internet, telephony, IPTV, for example, but more and more smart home applications, IoT, and other stuff that we haven't even thought of yet. And also, like the regular traffic, data is somewhat managed, because again, you can't tell the user exactly how to use their data in the home, but you have some control with the equipment, quality of service, VLANs, a couple of things like that. So it's very similar, and by this analogy, we can also learn from what we do. And that's, of course, the next question. What can we learn from this? And I have 3 examples for you to illustrate. And first of all, if you think about city traffic, everybody, I think, understands this is not a solution. If you want more data, more traffic, more bandwidth in your home, let's not build this. So in a city, this is very, very trivial to understand. Nobody would suggest to build roads like this in a city. But what about a single access point per home, which is up to now still quite often the target for operators to deploy, or for what people would really like? One device in your home and Wi-Fi coverage through the home. Great idea, but it's not likely to happen unless you're in a smaller apartment, and it might be fine, but not a solution for everywhere. So fortunately, most service providers these days realize this, so the mood is changing, so that's good. But we also don't want to go too far in a direction like this, for example. And this illustrates a little bit the meshing approach. Now, you can do meshing in different ways. You can do it well, and you can do it not so well. This illustrates a little bit, if you try to build a city like this, where every home is independently connected by road. Of course, there's not much space for homes anymore. The analogy to the home is you have these wireless solutions like 60 gigahertz, where the idea is really place one access point in each room in your house, because 60 gigahertz doesn't travel well at all, and definitely doesn't go through walls and so on. But then you're stuck with a large number of devices in your home, and you need to still get the bandwidth to all these devices. They cost money, so it's not an ideal solution. So again, in the city traffic, this is pretty obvious, but in home traffic, people still think that maybe this will work. And I don't think it will. And you already see here a little bit, these are of course a little bit black and white situations, either put huge roads everywhere or small roads to every individual house. So the value in the end is to think about the gray area in between. What is there in between these scenarios that could really work very well? Next example is a question on maximum speed. You see this a lot in consumer retail marketing. The access points with the more antennas, the bigger antennas, the better. If they look, I would say they look uglier, but they just look faster, then people buy them because they think it must be better. I'm not convinced this is a good solution. And if you look at the traffic analogy again, we have different types of roads for different purposes. We have pedestrian walkways, which are small, let's say, so you can build easily around obstacles. You don't have to rip out half the houses in the block to build the road. You can put the pedestrian walkways around. They're not so expensive to build, also important. But then, of course, cars can't drive on the pedestrian walkways. So we have roads for cars as well, which are asphalt. They're wider, they're smoother as needed. And the same thing happens in the digital home, where you have a wireless and a wired infrastructure, for example. I think it's obvious that wireless will never catch up with wired connectivity if you think about bandwidth and reliability. That doesn't mean it's not good to see if we can improve on the wireless. That's always good because it's a very convenient interface for people. But the way I think about it is then, in the analogy, let's improve our pedestrian walkways so that you can safely run on them instead of walk. But let's not try to turn them into highways. And as a result, that they would become a danger to pedestrians that want to use those same walkways, those same roads. And the analogy is a little bit with mobile devices. They have battery life, so if you try a blaster approach and you just need more power, more bandwidth, then your battery life might suffer, which is not a good thing. And the other aspect of it is if we want to build these big roads, we might have to tear down buildings to build them. Which is, in the analogy, you have to think about other standards that are using the same wireless spectrum, for example. You don't want to just push them out and make them unreachable. So you need to think about it carefully, and in my opinion, there's a limit to how far you should go with these different infrastructures. And one point is people who buy this car, they don't really need you to improve the pedestrian walkways. These people go to the racetrack to enjoy their car. So, moving on, my last example here is that we have to deal with legacy gracefully. Now, we already had a lot of discussions around DOCSIS in the panel and this morning. about what's going on. So I work for Genexis and we do fiber to the home, so we're focused on that. So for me it's easy, let's just forget about DOCSIS. But I think in reality there's plenty of room for both worlds, because the end game will be fiber, but fiber installations can only be done at limited speed. There's only so many people available to dig in the ground, put the fibers in, do the splicing, etc. And meanwhile, if consumers want more bandwidth, then also on the cable networks we have to provide solutions, or somebody has to. So there's plenty of space, but in either way we have to deal with the legacy. And if you look at a city, and as the picture suggests a little bit, I think it's obvious nobody would dare suggest to tear down a whole city and rebuild it, because we now have better ideas how to build houses and roads and deal with it. And certainly doing that would bring great improvement to the transport, because you have so much room to optimize, but it's just not going to happen. It's like with the traffic in the city, we can dream of a big bang of self-driving cars that will help improve the capacity of the roads. But somebody's going to have to pay for all these cars, and if you just bought a new car, you're not going to write it off immediately. So it's going to take 10, 20 years or however long to get going. And in networking, of course, we also understand we can't expect people to throw away all their existing client devices if you're talking about Wi-Fi. So the routers you have today are backward compatible. 11A, B, G, N, AC, upcoming 11AX. They'll all be supported. And this is important that we know this. But what about replacing all the infrastructure devices in your home? As I mentioned earlier, the big Wi-Fi blaster approach is not working anymore, so you need a kind of meshing solution. If you want to do that, you could build something new and then say to the people, look, now I have something much better. Throw out all your old infrastructure devices and use mine because it's so much better. It's also not going to happen. Now, until fairly recently, or even maybe today a little bit, it's still possible here and there, because the infrastructure device was really the router in the home, and that's one device. So if you're going to replace one device, it's not a problem. Once you reach the point that you have decided to replace that, it's okay. But this will change, and this is changing now. As more and more people invest in infrastructure in their home, they get the Wi-Fi extenders and other equipment. We have to deal with it in a graceful way, because people don't really like to throw everything out. Well, there is one way that the consumer might do that, is if you give them all this new equipment for free, but I think we're not prepared to do that. So what we learn is we need not only the backward compatibility with the older Wi-Fi standards, but we also need to look at the interop between devices and device vendors, and the coexistence between the infrastructure devices. And just as a small side note example of this dealing with legacy, I had a discussion with one of our customers not so long ago about 11B. Now, 11B standard for Wi-Fi was defined a long time ago, and you would expect, since then we had the 11G and the 11N, and now we have 11AC. So 11B should be out by now, but it's not. Unfortunately, we still today see new devices coming on the market, new client devices that are 11B only. And I also wonder, why would somebody do this? It's a really bad idea, but we have to deal with it, because somebody has bought a device and they expect it to work. So if we give them a router, we can do all the new standards we want, but if they see this device they just bought doesn't work, they're probably going to blame us because we're not interoperable. And one way to think about that and to deal with that is sort of having a default and escape strategy, where you provide a default where you can choose either I'm going for the maximum speed and I lose the compatibility by default, or you choose the opposite. I choose to be compatible with everything as much as possible at the expense that I mightn't be able to reach the maximum speed. Of course, if you have a very diverse group of customers, of end users, you don't know who will prefer what. So you have to take a pick, and then you have to make the escape easy for people, so that if in their situation the default doesn't apply, they want to choose the opposite, you make it easier for them to do so. And I'll come back to this a little bit later, because it's a very important part in deploying successful networks. So moving on, I think what I've argued so far is that it's clear we need a flexible and a scalable solution for this in-home distribution of all this bandwidth that we make available. And what we need for this certainly is technology to make things work, because without the technology there would be no bandwidth. So we see 10 gigabit Ethernet and the PON standards on fiber, no problem. We see the 802.11 AC today, the AX coming up, where the draft was, the second draft was released end of last year. So we're getting there. We see meshing technologies in retail, you can already buy them these days. And then topics like data analysis and machine learning that we also heard something of earlier today. Loads of technology to make it work. But this is not sufficient. What we also have to do, and by analogy here, I look at the subway and I ask myself, the subway is a great way of transport, but why is this? And there's a lot of technology in subway systems. You have to make the cars go, you have to dig the tunnels, you have to get people to pay, all these little gates, loads of systems, lots of technology involved. But there's more than that. There's also non-technology involved to make it easy. One of the big reasons why a subway or an underground is so easy to use is the coloring system, for example, for the different lines. You know instantly, even if you've never really used it before, you know instantly you can find which line is where the transitions are to change from one line to the other, and which line you're on. And basically all you need to know is the color and the direction you're going, and you can use the system. And the idea to color these lines is not technology, it's something else. So what we also need, apart from the technology to become successful, is the non-technology to make things easy. And it's important, the business we're in, we sell our products to the operators, but ultimately the end users are using this, of course. And if the end user is not happy with their subscription, if they're not happy with the Wi-Fi, then they're not going to buy the subscription for their internet access from this provider. So they're not going to buy our products, so we're not happy either. So we have to accommodate for both the operators and the end users. And here also I have 3 parts to the non-technology: easy installation, intuitive user experience design, and simple management. And I will tell you a little bit about these. So first, the easy installation. This starts on fiber deployment with a well-protected fiber. You know glass fiber is very easy to damage. We saw the testing story, how difficult it can be to make sure all the connectors are clean and the signals travel well. Doesn't just apply to the multi-fiber cables, of course, but in general. And if a fiber breaks, you have a problem, because then you need splicing. And like a copper cable, you can't just solder it back together. So you have to be very careful and think about how to handle the fiber in the home environment where the end user is around. They have children walking around, pets that might try to eat things or rip things from walls. We had a nice support case many years ago where the report was that the person didn't have internet access anymore. So you wonder, oh, it doesn't work anymore, what's the problem? And then you read down the report, and they said, yeah, our dog ripped the fiber termination unit from the wall, and now it's just hanging there on the wall, and it doesn't work anymore. And you go, yeah, I understand that it doesn't work anymore. This happens, and you have to be prepared for it and deal with it. So one of the things we also do is invest a lot in the development of our fiber termination units. Make it very easy, there are splicing options, etc. And then ultimately the fiber is very well protected so that the end user cannot access it, unless of course they really want to, they can break it open. But they can't by accident damage it, and it's very important. What's also important is not just that the fiber is well protected, but that the installation for the installer is very easy, because they have to go to somebody's home, screw this thing to the wall, put the fiber in, splice it, patch it up, etc. And this takes time, and time is expensive. So you want to be able to do the installation very quickly, so that is no problem. But then there's even more, because what also is important is that the installation time is predictable. And the idea here is, if you look back many years and somebody needed to come to your home to do an installation, you'd make an appointment and you knew that the installer would come on a certain day, and you probably take a day off. And then hopefully the installer shows up, does the work, and everybody was happy. But these days, it's like you go on the internet on Sunday evening to order something online, and you expect that by Monday morning they deliver it. So we are accustomed to a much higher level of service these days. And with the fiber installation, it might mean that you don't want to take a whole day off. You want to take maybe half a day off. So the installer has to tell you when he's coming, not just on which day, but what time of the day. And the more accurate you can predict that, the more happy the customer will be that they don't have to take so much time off. And one of the things we did in our latest generation products is to make the product much smaller. Now, if you make it smaller, it's much more difficult to put lots of technology inside, so it's a challenge for the engineers, but that's why we have good engineers. What it helps is the installation becomes more predictable. And the reason for that is fiber comes into your home in a particular location, and unlike copper cable, you cannot just move that point around by extending it very easily. So typically where the fiber comes in, that's where you need to install this unit. So you don't have that much control over it. It's often in the metering cabinet. I don't know if the situation is the same in the UK here, but in a cabinet where other gas, electricity come in your home, not a lot of space. And the problem is, if your device is larger, then it might be that the installer comes and he finds that he cannot actually install it because it doesn't fit somewhere. So he has to go looking for a different place to install it, move the fiber around, takes more time, making effectively the installation less predictable. And then the risk is that he shows up late for the next customer, which you don't want. So by having a short installation time and by having a more predictable installation time, you can plan more installation appointments on a single day, make more use of the people that you have do these installations, roll out faster. So quite important, and where at first glance something looks like, well, it's just a nice looking design, there's a lot more behind it to make it really successful. And it doesn't quite stop there with the easy installation, because it's great that the operator or the installer can mount it. But what you also want to do is help the end user. And this is the idea. The installer installs the fiber in the home and mounts the fiber termination unit, and then puts on a blind cover so it's well protected and it looks okay. But maybe the user doesn't have a subscription yet. Then the fiber is still already installed. And later, when they take a subscription, then you need to install the active equipment. So you postpone the capex of your active equipment. So the easy way to do that, or the easy way, is to send an installer again to the home to do the active installation. But this costs another truck roll, a lot of money. You don't want to do this. So by making this easier, you can let the end user do this. Despite the fact that it's fiber and it's a bit tricky, this an end user can do. It is so simple. Even without explanation, people figure this out. Now, interestingly enough, these kind of things are always harder than you think, especially when you have an engineering background. You think, oh, this is easy, everybody can do it. And then you find that it's harder than it looks. And if you really want to target everybody, even if people can do it, some people are nervous. They think, oh, this is fiber. I know it's tricky. What if I break something? So of course you can still get an installer to do this. But the beauty of it is, if you design it with the purpose that an end user can install it, it also makes it easier for an installer. And one of the key benefits in this scenario is that you don't need a trained, expensive installer to do it, but you can, for example, hire students to do this. And one advantage of students is they're cheaper, but a second and an even bigger advantage might be that students like to work in the evening because they study during the day, they have some time in the evening. And when do consumers like that you come to their home to do installation? Probably the same. If you come in the evening, they like it very much because they don't have to take time off work. So it's a win-win. And again, you get these compound factors that if you do things really well, they add up and you get so much more value out of it. Then second part, user experience design. Now you can already see in the picture, most people, when you talk about user experience, they think about a GUI in this kind of product. But this is not the whole story. The user experience really covers the whole product. So not just the GUI, but like I said, also the installation of it, the operator's use of the product, the end user's use of the product. Everything matters. And what I propose that we do here is, instead of designing a GUI and either say, oh, well, it looks really nice or it has all the features in it, let's think about it in different terms. And they're a little bit vague, but again, if you do it well, they help you to think about what you want to achieve with it, what kind of feeling you want to bring across. And one of those things is to think about invite over instruct. So what you want to do is to invite people to interact with your product rather than to instruct them with a manual, say you have to do this and this and this to install the product and use it. Similarly, you want to enable people to do something that they want to do instead of forcing them to do something. So if you enable them to do the things that they want to do, that they can make better use of the product, they will feel much happier than if you force them to go into a GUI and change settings to make it work. Again, one of those is discovery over fear. I think everybody knows, many people have a fear of these things. It's a complicated device, they don't understand it, but they do know if they make one mistake in the GUI, maybe they lose their connectivity. And that's bad enough, but then they have to call the help desk, so the operator is not happy because help desk costs money. And the end user is not happy because he doesn't feel very smart, because he just made a mistake that probably he should have known how to fix. So it detracts from the user experience, and it just makes your end user not very happy. But if you allow them to discover features without the fear of making mistakes, so if you have a way to back out of changes, to correct mistakes, or make it clear where something is really dangerous and where not, it becomes a much better experience for them. And then it is about being in control or feeling in control instead of a hassle. I think often with many devices these days, people feel it's a hassle. They get a new router, a new device. They have to just install it and make changes and do stuff. They just want to use the service. They want to watch TV. They want to do these things instead of having to do all the stuff that's not getting them to their goal. But if you do it well, then they feel in control, and it's a much happier way to think about it. If you feel in control of what you're doing and what your home looks like, it's much better than if you think it's a hassle that you have to do the wallpaper or the painting, etc. And there are many more ways where this way of thinking can help to figure out what can we do to make the user experience better for everybody. And then the last part here, simple management. Management is, of course, the provisioning of the devices, but also the troubleshooting. And what I find interesting is if we build these flexible, scalable solutions that I mentioned, then, of course, management becomes more of a challenge. So you might be tempted to see if we can go back to this one device kind of approach. But really, the one size fits all, sure, it may seem easier to manage, but it's not actually, it doesn't actually fit at all. So in the end, it'll just be more problematic because you get more help desk calls and more things you have to figure out how to get the user to get a good service. So what do we expect of a management system? And there are two parts to this. Again, as I said, especially in our business, it is, of course, what the operator wants. Our customer, if they want something, we might have to provide it. But it's also about what the end user needs. And then especially how we can bring the two together. And then what I propose here is to think about this as a three-tiered approach. So first of all, it just works, right? If we build good technology and we do our work well, then it should just work. We've had this dream about Wi-Fi for forever since Wi-Fi started. It should just work, and if it doesn't work, we just come up with the next standard and the next standard and make it better. But we never quite catch up. So this is not enough. It's a good target. We can get close to it perhaps, but it's not enough. The second part is that the end user should be able to help themselves. So we need some form of management for the end user. It makes them feel happier if they can fix a problem by themselves instead of involving the operator. Not only does the operator happy because it saves the help desk call, but the end user will be happier. But of course, not all end users will be able to fix a problem or understand it, or again, they're a bit nervous. So you still might need to revert to operator assistance, so the management by the operator is important to consider. And what is interesting here is we have continuously this operator and the end user dynamic. And what is clear to me is that what we need is a shared data model, because they operate on the same device, on the same in-home network in the end. So they need a shared data model that they operate on, but they need different optimized representations for their needs. Traditionally, an operator might use TR69 for the management. They need a bit more than just TR69, more than the protocol and the data model. It's a little bit like a book, which is a collection of words, but it's the story that matters in the end. So here also, you can have the TR69 protocol and the data model, but you need more to understand the data model and see it as a whole and present it in a good way to make it understandable. And the end user has different needs. You might provide a GUI or apps or however you want to do it. They operate on the same data model because they're ultimately changing the same device, the same settings. But the representation can be quite different to make it suitable for end user needs and capabilities. And then in this way we can let the end user and the operator help each other and make them both happy. And in fact, one thing that's also important, and I addressed this a little bit before, where we used to have one infrastructure device, the router, the access point. We get more devices now, so it's also very important to start thinking about the home network, not just as I have one device that I need to manage, but it's a collection of devices, and instead, in fact, you want to see this as a network view instead of a per device view. So again, your protocol, TR69, it can communicate to all the devices, but you need a representation that makes it much easier to see what's happening in the total network in the home. Just like you do that in a central part of the network. So my proposal is that it's not a fight after all. It often seems like a fight, this operator and end user dynamic, because the operator always seems to be complaining that people call the help desk so often and they have problems and it costs so much money. And the end user never seems satisfied with their service. They want faster and better and more and cheaper. But it's not a competition. We have to ultimately get things done together. And if we take care especially of the non-technology part, then the operator and the end user will both benefit, as I've shown in a couple of these examples. What is key in this is that the device manufacturers, they speak both the languages. The language of the operator, but also the language of the end user, to be able to bring them together. Now, you know I'm in fiber to the home, so you can also argue a lot of the topics that I've described are fairly generic. But how does fiber then drive this? Why do we know more about this than others, potentially? So one thing is, with a focus on fiber, all this for us is everyday routine. It's our core business. And the reason for that is fairly simple. Fiber drives the expertise on technology because we have a huge amount of bandwidth that we need to make available throughout the home. If people get a fiber subscription, they have high expectations, so we need to make it worth their while. If you look at a DSL network, the speeds are lower, so you also need less speed distribution through the home, so it's all a bit easier than on fiber. And also on the non-technology, we do a lot, and the reason here is that fiber often still needs to be deployed. We've touched on this a couple of times today as well. Many places don't have access to fiber to the home yet. So if this needs to be deployed, if you don't already have an infrastructure there, then the ease of installation is very, very important. Also, when you do this investment in fiber to the home, digging the ground up, putting the fibers in, it is expensive. So you need a high take rate. Operators typically look for 30 or 40% on the homes passed to get us active subscribers, and sometimes even higher. So it means you cannot just select a couple of high-end users or different user groups here and there. You need to make the user experience work for everyone. Otherwise, you will fail. And finally, I touched on it as well, living up to high standards. Just the idea, if people get a fiber subscription, regardless of speeds and what's behind it, just the fact that you get fiber to the home gives people higher expectations. They expect more from it. And in this case, that requires best-in-class management, so that really, if something goes wrong, everything gets resolved very quickly. So, in summary, where does that take us? Well, we started with technology. Again, we heard a lot about this today. But there's more than that. We need to combine that with easy installation, intuitive user experience design, and simple management. And then, when we combine all that, for both the operator and the end user, then we remain ahead of the game and we can make fiber deployment truly successful. Thank you very much.